last night I had the opportunity to go see a play at a local theater company here in Las Vegas, and it was about Watson and Holmes regarding Sherlock Holmes. And as I was watching this, I was trying to figure out, okay, where's the twist? How's it going to work? I missed it completely as far as the correct prediction. I was shocked, and there were several twists. It was a great play. We like to be surprised. Well, we may not want to be so surprised when it comes to IP networking. If we're trying to solve a problem or implement a solution, we don't want to be surprised by what happens in the packets or the frames as they're being forwarded across the network. So in this video, it's time for America's favorite game called Guess That Address. Take one. So let's discuss this network right here with our good buddy Bob the user, and then we'll take a look at what we're going to guess on. Okay, so Bob is sitting at his computer and he has opened up some application, maybe a browser, and he wants to go to a web server. In fact, he does. He wants to go to this web server right here. So at the top of the heap is Bob the user, and he's running a program called a browser. And behind the scenes, that browser is using an application layer service called HTTP, which is providing web services. So that's the application layer protocol from the protocol stack that's being used behind the scenes. Now it's Bob's intent that he gets his response from the server. It shows up right here. But behind the scenes, the computer is still completing the details regarding the TCP/IP protocol stack, including adding the Layer 4 protocol that's used for HTTP. And I've got a question for you. Do you recall the protocol that's used at Layer 4, the transport layer, for HTTP? What does it choose to use at Layer 4? And if you're saying, Keith, that's the Connection-Oriented Reliable TCP, Transmission Control Protocol, you're spot on. We'll add that next. So the TCP header gets added, where Bob's computer chooses a high-numbered source port and the destination well-known port of HTTP, which is port 80. And as the encapsulation continues, Bob's computer adds the IP header information with the source and destination IP addresses, which are going to be Bob's PC as the local IP address. He's at 10.16.0.10, and the destination IP address of the server is 192.168.1.100 right there. And the encapsulation continues as Bob's computer adds the layer 2 information, which would include the layer 2 and Ethernet. That would be MAC addresses, the physical addresses, hardware addresses that are burned into each of the network adapters on Bob's computer and all the routers and the server. And finally, those bits from Bob's computer are spit into the network. We can think right here of it as go, 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 get the job done. Then it's up to the switches to do layer 2 forwarding, and the routers as shown here to do layer 3 forwarding until that data gets to the server, which can then de-encapsulate that information and then respond back. So in this table up here, I've got the layer 2 addresses of all these devices in the topology and the layer 3 addresses of all the devices in the topology. So this network right here that Bob's on is the 10.16.0 network. The network between R1 and R2 is the 10.16.6 network. The network on the right-hand side of R2 is the 192.168.1 network. And R1 is using .1 for its host IP addresses, and R2 is using .5 for its last octet of its IP addresses. And as we mentioned, Bob's at .10 and the server's at .100. I also have the layer 2 and layer 3 addresses for all of this right here in this table. So what I'd recommend you do is pause just for a moment right here and take just a moment to look at this table, just to get an idea of what those IP addresses are for each of these devices in the network. Now for the MAC addresses, it's not going to be very easy to memorize all those, so maybe we focus on the last 6 characters or the last few characters for each one. Because in a moment, we're going to play the game called What is the appropriate layer 2 and layer 3 addresses if, and this is the key part, if we were to take a look right here at point A on the network, or if we were to take a look right here at point B on the network, or if we were going to take a look right here at point C on the network. And that's what I like to call the guess the address game on a computer network, to guess what the layer 2 and layer 3, really not guessing because we have the table that shows all the addresses, layer 2 and layer 3, but really correctly predicting what those addresses are going to be. So here's what I'd love us to do. If you've been through the training up to this point with Jeremy and you have understanding of these concepts, I'd like you to pause it right here and fill out that information. What is the appropriate layer 2 and layer 3 address at point A, point B, and point C? And then when you're ready, click on resume and we'll review it together to compare our answers. And this is just going to help reinforce the ideas and the concepts regarding how IP networks really work end to end. So I'm going to put some music on just for a few moments, hit pause, and when you're ready and you've answered these questions, click on resume. Do 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 So let's begin by taking a look at point A in the network. And if we were to do a protocol analyzer at that point, what would the layer 3 and layer 2 addresses be for that packet and frame respectively at that point? Also, I color coded these, so the layer 3 is the same color as this layer 3 in our TCP/IP stack, and I also color coded layer 2 as well. All right, so if Bob is trying to access 192.168.1.100, that's the goal, and his source address is 10.16.0.10, the source IP address is going to be 10.16.0.10, which is Bob's address, and the destination is going to be the server at 192.168.1.100. And that's the server's IP address right there. Now, if we just had a protocol analyzer, we actually captured the data, we could actually prove it by looking at the details in a protocol analyzer. Well, the great news is, I've got one. Let's take a look. And here it is. So if we look at this packet 6 in this capture, the source address is 10.16.0.10. That's at layer 3. And the destination address is 192.168.1.100, the server. So this is part of the HTTP conversation they're having. So at the application layer, it's HTTP. At layer 4, it's TCP. At layer 3, which we're focusing on here, the source address is Bob's computer and the destination address is the server. And I've got news for you too. Unless we're using NAT, which we'll cover in a later set of skills. This is called network address translation, where we're lying or swapping out IP addresses. If we're not using NAT anywhere in our network, this layer 3 source address and the layer 3 destination address is going to be the same at point A and point B and point C, because that's where Bob is really trying to go. He's trying to reach this server at 192.168.1.100. His source address is 10.16.0.10. So by default, those source and destination IP addresses are going to be the same at point A, point B, and point C. So now we've identified that short of NAT or any kind of IP address swappery, we're going to have the same source and destination layer 3 addresses, the IP addresses, for the entire path across the network. Now what is going to change is the layer 2 information. And that's because layer 2 Ethernet addresses are not used for end-to-end connectivity. They're used just in the local segment, the local VLAN that they live in. So let's play this game called Guess the Address again, but now we'll do it with layer 2 addresses each step along the way. So let's start with point A regarding layer 2 Ethernet addresses. If Bob is trying to reach 192.168.1.100 and he's on the 10.16.0 network, his computer says, whoa, different network. I'm going to need some help from the default gateway. So Bob is going to forward at layer 2. He's going to forward to his default gateway. And that's going to be the layer 2 address we would expect to see at point A in the network. So the source MAC address would be Bob's layer 2 address, his Ethernet address, which is this bad boy right here, the one ending in 778899. And the destination layer 2 address should be the router 1 gig 00 interface right here on this local segment, which is this bad boy right here, which is ending in 800A. And you know what? If we go back and take a look at that protocol analyzer that we just looked at a moment ago, we can look at the layer 2 information to confirm exactly that. So this is the exact same packet capture that we looked at just a moment ago, but this time as we take a look at the layer 2 information, and we'll go ahead and expand that, the source MAC address is this one here, Bob's, ending in 778899, and the destination layer 2 address is router 1's 0/0 interface, which is the default gateway that Bob's using that ends in 21800A, just as we expected. So my question is, how are you doing? Did you predict that correctly? Well, let's do one more, and let's take a look at the packet/frame as it crosses between R1 and R2, and let's make a prediction about what we think the layer 2 address will be at that point as the traffic is being forwarded from R1 to R2. So take a moment right now, think this through, come up with your prediction on what you believe the layer 2 address would be for the source and destination picked up at point B in the network, and then resume me and we'll take a look at the answer together. All right, let's compare notes. Well, if router 1 receives a packet that's destined for 192.168.1.100, it's going to look in its routing table. Now, we're going to have separate skills on static routing and dynamic routing. Those are all coming up. But the basics is router 1 looks at the layer 3 destination IP address and says, do I know how to forward this? And the routing tables, the forwarding table, tells R1 to forward it over to R2. In order for router 1 to get that frame of data over to router 2, so router 2 can then do a routing decision and move it on, router 1 needs to implement at layer 2 its own source MAC address here on its 1/0 interface. So if we look at the table here, R1 1/0 it would be this MAC address ending in 8028. That would be the source. And it would use the destination layer 2 address as R2's layer 2 address for its 00 interface, which is this one right here. And that would go right here. So what we'd expect to see if we looked at the frame at this point, right here between R1 and R2, we'd expect to see a source layer 2 address ending in 8028 with the destination layer 2 address of 0008. So if we focus on just those last 4 characters, it's a lot easier than memorizing the whole enchilada. So we're looking for 8028 source going to 0008 as a destination. So let's pull up packet capture and take a look. So in this packet capture, it's still carrying the HTTP protocol at the application layer. It's using TCP at layer 4. It's using IP at layer 3. There's the source and destination IP addresses. And check this out. This is the capture, once again, between router 1 and router 2. And if we look at the source MAC address, the source MAC address is the one ending in 8028. And that's the router 1 1/0 interfaces layer 2 address. And the destination layer 2 address is the one ending in 0008, which is R2's 0/0 layer 2 address. So up to this point, we've reinforced the idea that the layer 3 information, the source and destination IP address, stays the same from source to destination. That way the packets can get where they need to go. They're routed to the right location. But every hop along the way, the layer 2 addresses are swapped out with the next device in that forwarding path. So are you up for a challenge? Because I've got one for you. And here's the challenge. I think you're going to be up for it. I think you'll like it. At point C in the network, my question for you is, at point C, what is the source layer 2 address going to be? And what is the source destination layer 2 address going to be at point C here in the network? So all the information regarding the layer 2 addresses, including the server's layer 2 address, are right here in this table. And what I'd like you to do is I'd like you to calculate or determine what you think it will be. So that's my challenge for you, is for that last segment to calculate what the layer 2 addresses will be. And when you solve that, feel free to shout it to the world. You can put it on social media. You can reach out to me on Twitter or Facebook or wherever you want to reach me and say, hey, got it. Got the answer to that last segment. I know the layer 2 addresses, and they are, boom, let me know. I would love to hear about your progress and your journey through the world of networking. So in this video, we've done 3 basic things. Number 1, we've reinforced our idea, our knowledge about how the TCP/IP protocol stack works. Great job. 2, we've identified the types of addresses that are used in networks at layer 3 and layer 2, and we've also predicted, based on a stream of traffic, what those addresses are going to be. So if you've done all those and you've done that extra bonus challenge, my hat's off to you. Way to go. So I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.